Well, okay, here are the answers to the homework you have for tonight. So I would really encourage you to try the problems first, then come over, pull up this video, pause the video, check your answers, correct any mistakes you had, and make sure you understand why you made them. And then if you do have questions at the end of the video that I didn't cover in the video, make sure that you come back to the Google Meet and ask. So let me just keep going through. Pause the video as you need to check these answers. And these are the 3 flow charts at the end. So I thought that you might have a couple questions on some of the more, let's just say, challenging problems. So here are the 3 that I thought people probably would want to see worked out. Let's go ahead and start with problem number 9. Okay, so in problem number 9, we have a lot of stuff going on. First of all, when we ask my favorite question, which is how many triangles are in this picture, you see there are 2 triangles in this picture. And so one thing that you might find really useful is I went ahead and I marked that angle A is equal to itself. Notice angle A is in both triangles. But one thing sometimes kids find useful is to redraw these 2 triangles and orient them. But that might come easiest after you set up your similarity statement. So I know we have triangle ABE, and I want to make sure I label everything, like 4, 3, X, double arc, single arc. But what about the other triangle? Well, notice that triangle ABE is similar to the bigger triangle. And this similarity statement is the key to finding X and Y. So let's take a look. A has 2 marks. In the big triangle, A also has 2 marks. B comes second in the small triangle, and B has 1 arc. So in the big triangle, notice D has 1 arc. That would mean by default E, which is the third vertex, it has no arcs, has to match C. And once we get that statement that triangle ABE matches triangle ADC, we can do 2 things. We can redraw both triangles and orient them the same way. A in the small triangle goes with A in the big triangle. B in the small triangle goes with D in the big triangle. Notice D has 1 arc, so does B. And then finally E in the small triangle goes with C. So having that similarity statement where we matched up the corresponding parts helps us redraw this shape. Now let's label the big triangle. So first of all, A has 2 arcs, D has 1, C has none. We know that AD has a length of 10. We know DC has a length of 6. And then AC has a length of X plus Y. So let's see if we can use this similarity statement to find the missing pieces. So looking at these 2 triangles, I think that the corresponding sides that I'm most interested in are these 2 because they deal with actual numbers, no variables. So if I set up a ratio of my triangle similarity statement, ABE on the top, ADC on the bottom, I can now fill in a proportion. 3, which is EB goes with CD, which is 6. The same way, now looking at this triangle, X, and X is AB. AB goes with AD, which is 10. And now I can cross multiply and I can find X. 30 equals 6X. So X equals 5. And now that I know that X is 5, I can put a 5 here. Now, let's use the same proportion to set up, or the same comparison to set up a new proportion. I know 3 goes with 6, 3 goes with 6, 3 goes with 6. The same way 4, which is AE, goes with AC. And I'm just going to call that AC because AC mixes X's and Y's, and I just don't want to do that. So cross multiplying, we get 3 times AC equals 24. And when I divide both sides by 3, I get AC equals 8. Now remember, X is 5. So I can come in here and change this X to a 5. And AC is 5 plus Y. AC is 5 plus Y. And that's supposed to be 8. So that tells me Y is 3. And that was a really tough problem. I think that's the type of problem that would be an extra credit type problem because you have a lot going on. But if you stay organized and you use this similarity statement, again, we see how that similarity statement is the key to setting up all proportions. It isn't awful. Now let's come down here to problem number 10. I thought this one was a pretty tough one too. So what do we know about these two triangles? Well, we know we have one pair of equal, oh, look, we have two pairs of equal angles because what kind of angles are these? Well, I hope you just said they're vertical angles. So we know that both of these triangles are similar to each other. Now, we could try to write a similarity statement, although it looks like these triangles weren't named. So maybe what we'll do instead is we'll redraw the triangles matching up the corresponding parts. So here is this original triangle, this red triangle right here, N, 45, and 63. And what I'm going to do is I'm going to do this green triangle so it matches the red triangle. So I'm going to put the double angle, oops, that was wrong. I'm going to redraw it here. I'm going to put the double angle in the bottom right hand corner just like I did here. I'm going to put the single angle with the hash mark in the bottom left hand corner. So let's label these pieces. S falls between my two labeled angles. So this would be S. 30 is between the double arc and no arcs. So this would be 30. And 36 falls between the single arc and no arcs. So that's 36. So I can go ahead and set up my proportions based on this picture. Now, these two sides are the sides that are most attractive because they don't involve any variables. So I could say 45 is to 30 the same way N goes with 36. Now, you might reduce this fraction, I think 15 goes into both of these, into 3 halves. So now you can cross multiply and get 108 equals 2n. So n equals 54. And we can use that same 45 to 30 ratio or 3 to 2 to find S. 45 is to 30 as 63 is to S. And again, we could cross multiply and get S equals 42. And finally, there's one more problem left that I thought was fairly tricky, and that was problem number 14. And so if we look at problem number 14, our job here was to create a flow chart to show these two triangles are similar. So we have 3 ways of showing triangles are similar. They could be AA similarity, it could be SSS similarity, or it could be SAS similarity. And in this case, I have some side measurements. So I'm guessing it's one of these two. Now, if these triangles were right triangles, then we could find that third side by using the Pythagorean theorem. But there's no evidence that these are right triangles. So I'm going to guess this is probably going to be SAS similarity. But let's see if that's the case. I guess the first thing I'm going to do is I'm going to find which sides correspond to which other sides. So 20 is the biggest side, so is 8. And then 15 is the smaller of these two sides, and so is 6. So it looks like in my blurbs here, I'm going to compare 20, the longest side, to 8, the longest side. And let's see, both of those are divisible by 4. And so this reduces down to 5/2, or 2.5 if you're using a calculator. In the other ratio, 15 to 6, the biggest number to go into both 15 and 6 is 3. 3 goes into 15 5 times, 3 goes into 6 twice. And so yes, these are proportional. So we have two sides, but what about an angle? Well, notice that vertical angles are equal. So I can say, and again, we can't call this P because you don't know which angle you're talking about. I could say angle EPR is equal to angle UPS. And again, anytime you're dealing with something that wasn't given to you, you have to give a little reason. So I'm going to say vertical angles are equal. And we have all three bits of information that we need in order to say these two triangles are similar. So triangle, let's see, SPU is similar to triangle, well, let's see, S is next to the green piece and it has no arc measurement. E is next to this green piece with no arc measurement. So I think E goes with S. P goes with P. And U, which is right by the yellow segment, would go with R. And my reason is SAS similarity. Now, if you have questions about anything else, this is a great time to come back into the Google Meet and ask me. Ask me any question you want, and we can talk through it.